Hi all, I'm K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, let us see about the Bluetooth protocol architecture. So understanding the user needs for the Bluetooth protocol architecture is crucial because the design of the protocol must align with how people actually use the wireless device in everyday life. So instead of focusing only on the technical performance, the architecture is shaped by real world expectations such as ease of use, mobility, and reliability. So the first one is the users expect the devices to connect instantly without the complex configuration. Next, users want the uninterrupted communication between the devices like phones, earbuds, and laptops. And also, modern users are always on the move. So they expect that they not have any cables for connectivity while walking, driving, or working. Battery life is a major concern, especially for wearables and IoT devices. And while many applications are low data, users still expect quick performance. And users operate devices in crowded wireless environments, say home, offices, and public spaces. So reliability in real environments are very, very important. And users are increasingly concerned about the data protection, security, and privacy. And also, users own multiple devices from different brands. So compatibility across the devices is very, very important. And users expect to handle multiple use cases. So it has to support diverse applications, and for activities like gaming or voice calls, delay should be very low and real-time response is critical. So minimal latency for real-time applications is very much in need. So these are all the user needs. Uh, so the Bluetooth architecture determines which function should be operational in an implementation and how they should be organized. So first, a Bluetooth device is composed of two types of elements, a host and one or more controllers. So the host serves as an interface for applications on the operating system and implements the protocols of the higher layers. So it communicates with the OS applications to perform tasks with Bluetooth. And the controller implements the basic functions and protocols of the stack and supports the different Bluetooth technologies. So the host can be seen as a computer running the Windows that receives the processed Bluetooth packets and communicates with the user applications, while the controller would be the Bluetooth USB dongle that runs the firmware and performs low level tasks such as capturing the packets, announcing the device channel synchronization, etc. Host and controller communicate with each other using the host controller interface, which is known as the HCI. Packet transmission protocol, allowing the host to send the actions to a controller and receive the events in response, controlling the state of communication at a high level. A controller can support the VR, EDR, or low energy, or combination of both, while the host is the same for both the technologies. So this is because the fundamental differences are found in the lower level protocols of the stack, physical and media access protocols, each implementing its own set of commands and packets, while the higher layer protocols implemented in the host are not exclusive to the BR, EDR or LE and are common to both. Thus, a host can speak to any controller in the same language. The controller must implement the support for BR, EDR, and BLE and in a agnostic to the host. An interesting consequence of the separation between the host and the controller is that the host does not have information on everything that happens in the controller. Only where what the controller informs it of the through HCI packets. So this is especially relevant because in complex systems like PCs and smartphones, the host is generally implemented as part of an operating system, while the controller is in the firmware of a separate hardware peripheral over which the OS does not have any direct controller. So that is user interacting only with the host will generally not have control or knowledge of what happens in the layers implemented in the controller, since it is an isolated element, usually with the proprietary firmware from the manufacturer. So next we'll see about the protocol stack. So it consists of the radio baseband, then link manager protocol, then logical link control and adaptation protocol, and RFCOM, and TCS, OBEX, WAP, SDP, and finally the application or profiles. So let us see one by one each. So first, the Bluetooth protocol stack consists of multiple layers. So each responsible for specific functions to enable reliable wireless communication between the devices. So let us see about each layer uh, one by one. So the first one is the Bluetooth RF layer functionality. So it specifies the air interface, including the operating frequency, frequency hopping, and transmit power. It performs modulation, demodulation, the digital data into radio frequency signals, and it defines the physical characteristics of the Bluetooth transceivers and supports two types of physical links: connection oriented and connectionless. So next one is the baseband link layer. So it acts as the digital core of the Bluetooth system and equivalent to the MAC sublayer in the LAN architecture. It handles connection establishment within a Piconet and manages the device addressing, packet formats, timing, and power control. The next one is link manager protocol layer. So where it manages the established links between the Bluetooth devices, which is responsible for authentication, encryption, and security management, and creates, monitors, and terminates links based on commands or failures. So next one is the logical link control and adaptation protocol, which is known as L2CAP layer. So it's known as the heart of the Bluetooth protocol stack. It provides communication between the upper and the lower layers, which performs segmentation and reassembly of the data packets and supports multiplexing of multiple logical connections over a single physical link. So next one is service discovery protocol. So it enables a device to discover available services on another Bluetooth or enabled device, allows applications to determine the capabilities and services supported by remote devices. So next one is the RFCOM layer, where a cable replacement protocol that emulates the serial ports. So it provides serial data communication over the L2CAP, and it supports protocols such as WAP and OBEX based on the ETSI TS07.10 standard. Next one is the OBEX, which is the object exchange. It is used for exchanging the objects such as say files, images, and contacts between the devices. Commonly, it is used in file transfer and data synchronization applications. And wireless application protocol, it enables the internet access and web-based services over the Bluetooth and used mainly in older mobile and embedded systems. And finally is the telephony control protocol, where it provides telephony services over the Bluetooth and supports call setup, call release, and group management. And it's used primarily for voice gateway and cordless telephone applications. So you hope you understood the Bluetooth protocol architecture in detail. So we saw about the hardware relationships. So what is the host, what is the controller, what is the relationship between the host and the controller. And we saw the different layers like application layer, middleware layer, data link layer, and the physical layer. So let us take up some assessment questions. So which protocol layer is responsible for the segmentation and reassembly of the packets in the Bluetooth? Yes, the answer is L2CAP. Next one is which Bluetooth protocol enables legacy support for serial port emulation? The answer is RF COM. Thank you for watching this video.